Student, today we will learn the chapter Limits, Continuity and Differentiability. Student, as already we learned in the previous video in detail about the limits. Now using the limits, how we can find out the continuity and what is the meaning of the continuity. Today our topic is continuity. Student, as you know the meaning of continuity, here is a graph. This graph is continuous to going anywhere. Okay, if here is a breaking at a point, it is not continuous at this point. Okay, if you want to be check the continuity of this curve at a point or in any interval, or here is a point, it is discontinuous at this point. Discontinuous and continuous, this word you should be clear using now this curve. Okay, this is not continuous here, discontinuous, and this is continuous at this point. In this interval it is totally continue, and in this interval it is not totally continue because it is discontinuous at this point. It is continuous on the left side, but it is, and also it is continuous on the right side of this point A. Okay, so it is totally continue. It is not continuous at this point. It is continuous on the left side. It is discontinuous. It is continuous on the right side. So left side continuous, right side continuous, total continuous, discontinuous. These all words we have to explain here. Okay, as already we explained the meaning of RHL and LHL and FA. Let me define it again. Let a point we have to find FA, means put the value of a in the given functions. Okay, put x equal to a directly and you can find FA. And how you can find the RHL? Taking the right side a small value h, putting the value a plus h, we can find this value, that is fa plus h. Now h tends towards 0, so it is a very small value towards the right side. And similarly, if here is the left side, we can take very small value, then it is a minus h. Then for this we can say LHL, left hand limit fa minus h, where h tends towards 0. Okay, sometimes it is also written as fx x tends towards a plus, and it is also written as fx s tends towards a minus. Minus means left side, here plus means right side. Okay, it is directly putting the value. So these three terms you have to learn first. Okay, now if this curve is for both LHL and RHL, so we can use the same curve for both LHL and RHL and FA also. It may be given in the questions that LHL the another curve and RHL is the another curve. Okay, so student, now when this will be continuous, when this will not be continuous, what the curves are continuous always, this I am going to be tell you in detail. Okay, so student, now this is the main point you have to note down and you have to remember it. A function fx is said to be continuous at a point x equal to a of its domain if limit x tends towards a of fx, limit x tends towards a of fx is equal to fa. Okay student, here I am not writing the value positive or negative, means it is LHL also, it is RHL also, both should be equal to fa. Okay, in symbolic we can write this way: fx is continuous at x equal to a implies that limit x tends towards a fx equal to fa, and it is also, we can write this way, limit fx x tends towards a minus means LHL, and limit x tends towards a plus of fx means RHL is equal to fa. LHL equal to RHL equal to fa. Okay, so this is the main conditions. Now important point is that if fx is not continuous at a point x equal to a, then what we should say? Then we should say it is said to be discontinuous. At x equal to a. Okay, so student, we can say if limit x tends towards a of fx LHL and fx limit x tends towards a plus equal not fa, equal not fa, then the discontinuity, then the discontinuity is known as, now the special word we are using, then the discontinuity is known as the removable discontinuity. Removable discontinuity. Okay, why it is this removable discontinuity? Because fx can be made continuous. You can make fx continuous by changing, by defining it at point, another point, let x equal to x equal to a in such a way that fa equal to limit fx x tends towards a. You can set your questions for continuations. Okay, now next point you should be understand. If limit x tends towards a minus means fx limit, and also equal not limit x tends towards a plus of fx, then fx is said to have a discontinuity of first kind. So this word you have to remember, discontinuity of first kind. So what is the removable continuity and what is the discontinuity of first kind? Okay, so this you should be understand. Now a function fx is said to have a discontinuity of the second kind. This point you have to learn second kind. At x equal to a, if and only if and only if, this word you should be understand, limit of RHL fx or limit R LHL and RHL or both don't exist. Okay, if both limit or any one limit is not exist, then it is said to be second type discontinuity. And now a function fx is said to be left continuous or continuous from the left, at x equal to a if condition number 1, limit x tends towards a minus fx exists, and also limit x tends towards a minus fx equal to fe. Similarly, a function fx is said to be right continuous or continuous from the right side. At x equal to a, if and only if, again two things, limit x tends towards a plus fx exist, and this limit is also equal to fa. So student, I am detail given. Fx is continuous at x equal to a if it's both left as well as right continuous x equal to a. Okay. Hence, fx is continuous at x equal to a if and only if it is both left and right continuous at x equal to a. If and only if LHL equal to RHL equal to FA. So this is the basic formula. So we can use some above formula. We can say some following point. We can say a function fx fails to be continuous at x equal to a if in any case the following reason. What may be the reason? Number 1, limit fx x tends towards a exist, but it is not equal to fx. And second reason may be limit x tends towards a fx does not exist. And any reason may be also LHL does not exist, or RHL does not exist, or both does not exist. LHL does not exist, or RHL does not exist, or LHL equal not RHL. Okay. Or fa does not exist. So above following reason, we can say the function is not continuous. Now, some algebra for continuous. If f and g are two real functions, continuous at x equal to a, then we can say f plus minus g is continuous, fg is continuous, one upon f is continuous if fa equal not 0, 1 upon g is continuous if 1 upon g equal not 0, and we can also say f upon g is continuous if 1 upon g equal not 0. Okay. If ga equal not 0 here, ga equal not 0. Now student, we can use some more formula for composite function. Okay. If fog is defined and if g is continuous at x equal to a and f is also continuous at ga, then fog is continuous at x equal to a. So this is for composite function. And now for interval, a function f(x) is continuous on an open interval a to b. Function f(x) is continuous at on an open interval a to b if and only if, means if it is continuous at every point of the interval a to b, at every point of the interval a to b. Okay, and similarly a function fx is said to be continuous in closed interval. A function fx is continuous on a closed interval a to b if number one is condition, it is continuous on the open interval, it is continuous on the open interval a to b, and second condition is it is right continuous at x equal to a, right side of a. Okay, right side of a. It means fx x tends towards a plus RHL of at a equal to fa, and third should be it is left continuous at x equal to b, i.e. limit x tends towards b minus fx equal to fb. So you should understand a to b, RHL of a and LHL of b, and continuous from a to b. Understand? And we can say next point is fx is said to be continuous function if it is continuous at each point of its domain. Okay, a function fx is said to be continuous function if it is continuous if each point of its domain it is continuous at each point of its domain. Okay, and Next point is, we can say a function fx is said to be everywhere continuous. Note down this point, everywhere continuous if it is continuous on the entire real line, on the entire real line minus infinite to infinite, then it is continuous for everywhere. Okay. Now we have already described addition, subtraction and divisions and composite functions. If two functions are continuous, then they are also continuous. Now we have to remember some more important point. If f is continuous on its domain D, then mod f is also continuous on domain D. Okay, but if f is continuous on its domain D, then f may not be continuous on domain D. Okay, now a constant function, important point is a constant function is everywhere continuous. The identity function a polynomial, the modules function, and exponential function, and logarithmic function, logarithmic function, and sine and cosine function, leave it, logarithmic function, exponential functions, sine and cosine function, are everywhere continuous. Everywhere continuous. Okay, and logarithmic functions and in trigonometry we can take tangent, cotangent, cotangent, secant and cosec, cosant functions and inverse function, inverse trigonometric function, are continuous in their domain, in their domain. Okay, so this is the important point. We should be learn about the continuity. Now RHL equal to LHL equal to FA, this is the mean point of continuity. Okay, now do some questions. Show that the functions fx given by the following is continuous at x equal to 0. Show that the function fx given by fx is defining here two functions, x sine 1 upon x and 0. This is when x equal not 0. This is when x equal to 0 is continuous at x equal to 0. X equal not 0 here means we can take RHL here also and LHL here also, and FA we should take in this function. Okay, so LHL and RHL both we have to take here. Now solution of this. First we take LHL. So we can say at x equal to 0 we can say f0 minus h, h tends towards 0, and this function, or we have put here minus h, h tends towards 0. In our questions we will find here limit h tends towards 0. The function will take x sine 1 upon x, so minus h sine 1 upon minus h. Okay, and we can write here minus h. Sine minus theta is minus sine theta, so we can take h tends towards 0 sine 1 upon h. Now sine 1 upon h and some value between minus 1 to 1. Okay, so we can write putting h 0, and for sine 1 upon h we can write an oscillating number between minus 1 and 1. So multiplying this we get 0. Okay, now simply we can take for RHL at x tends towards 0, we can say 0 plus h tends towards 0, or we can say fh tends towards 0. Similarly, we can put in the first function also h sine 1 upon h tends towards 0. So same thing here, we can put here 0 and we can say an oscillating means variation, okay, number between minus 1 to 1. So multiplying this we also find the 0. Now third point is fa. This will be taken in the next function, that is given 0. Hence we can say LHL equal to RHL equal to f0. Hence fx is continuous. At x equal to 0. Okay, now take one more questions. Show that the function fx is given by fx, same we can use here e to the power 1 upon x minus 1 upon e to the power 1 upon x plus 1 when x equal not 0 and it is 0 when x equal to 0. You can see here RHL and LHL both come here and FA both come here, right? Is continuous, is discontinuous at x equal to 0. So we have to check it is continuous or discontinuous. So now we can take same method LHL f 0 minus h tends towards 0 equal to f minus h tends towards 0, putting the value here e to the power 1 upon minus h minus 1 upon e to the power 1 upon minus h plus 1. Now we have to evaluate this limit at tends towards 0. So we can write here is minus, so here is also minus, so reciprocal of this we can take 1 upon e to the power 1 upon h. So we can write here 1 upon e to the power 1 upon h minus 1 upon e to the power 1 upon h plus 1, h tends towards 0. Now when you put this limit here, e to the power 0 means it is infinite. Okay, so 1 upon infinite is 0. So we can conclude it here, e to the power 1 upon 0 means e to the power infinite. Okay, now 1 upon e to the power infinite means 1 upon infinite is equal to 0. So we can write here 0 minus 1 upon 0 plus 1 equal to 1 upon minus 1 equal to minus 1. Now for RHL, same thing, f 0 plus h tends towards 0 equal to f plus h tends towards 0. We can write e to the power 1 upon h minus 1 upon e to the power 1 upon h plus 1, h tends towards 0. Now same method, we can solve this one. Now taking the common e to the power 1 upon h, we can write 1 upon e to the power 1 upon h. Okay, h tends towards 0, cancel out this. Now putting again here, we can write 1 minus 0 upon 1 plus 0 equal to 1. Now fa is not continuous as equal to 1, has a discontinuity at first kind at x equal to 0. Now it is given f 0 equal to 0. So LHL equal not RHL equal not FA, hence it is not continuous, means it is discontinuous of first kind at x equal to 0. I have already explained what is the first kind discontinuity. If fx LHL equal not RHL, if LHL equal not RHL, this is first kind. Okay. Since both are exist but equal not, so therefore it is kind first kind. If one is not exist or this not exist or both are not exist, then we can say the second type. Now it is the first kind of discontinuity. Okay, so student, this way you can solve the continuous chapters. Now thank you for watching.